y2. The gradient, what's gradient? M is equal to.
So there should be audio coming through now from me, right? All right, so yeah, so today we're going to talk about matrices, and the idea behind matrices, as we were talking about it at the start, you know, matrices has a lot of applications in real life, but specifically for you at the moment, you need to learn the basic skills in solving matrices, perform some basic operations, you know, add, subtract, multiply matrices. And then, you know, we need to learn how to find the inverse of matrices. We need to find the determinant of matrices. Now, at this level of math learning, most of the things that you're doing are just steps that will prepare you for later mathematics. You know, so if you're going on into A-level mathematics or going out into business, these are going to be very powerful tools that you'll use. But for now, I think you'd say your number one reason to doing this is that it's on the syllabus and you need to learn it. So what I'll try to do is find the balance between a conceptual understanding of matrix, so you really know why we have it and understand how it works. But at the same time, I'm going to try and provide that balance so that you'll be able to do your steps that the exam will need from you and be able to practice that. So I think I should have audio going through clearly now. You know, so let's get going. So those are the objectives for today, and hopefully I meet those objectives. I think I have about 45 minutes. I'm going to try my best to make sure that I stick to that time. All right, so what is a matrix? Now, the first time you hear the word matrix, everyone go, yeah, I know the movie. And the thing is, the funny part of it is that when I was a child, we know of the matrix in terms of the math part of matrix before the movie came out. So for me, it tells you how old I am. So when matrix came out, it was another use of the word that we heard the word matrix and went, hey, there's another use for it. And so the idea of the matrix is the one that with Neo and all that kind of stuff. But the reality of it, when we talk about matrix, we're talking about an arrangement of numbers, objects, letters, anything, to be honest, that's arranged in columns and rows is in a matrix. So, you know, if we have numbers like these, in this case, this is considered to be a matrix. And what you have to bear in mind is that there's this organization, you know, like we have rows going across like that horizontally, and we have columns. And normally what you'll have for a matrix, you'll have a pair of brackets to enclose that matrix. So there are different types of matrices. So you will see there's no one rule about what they should look like. The main thing is that there are rows and columns. And I do remember when I was doing economics at the university, I remember coming across a matrix with maybe about 10, you know, 10 by 10. It's massive stuff that's happening there. So always bear in mind that there's no limit. But when you're studying, you know, at CSEC level, there's going to be a range and it won't get beyond those sizes. You know, you might not see a matrix with more than 4 columns or 4 rows. But the operations that you do are essentially similar. So it really doesn't matter whether you have a lot of rows or columns. The main thing is that it's organized in like a table in this way, as I said, in rows and columns. And it could be numbers, it could be letters, it could be pictures, it could be anything. The main thing is that the matrix is the structure of the thing that you're working with. So I said the matrix is normally described by the number of rows and columns in that order. So whenever we talk about a matrix, we try to understand that matrix by stating the rows and the columns. And by doing that, we've essentially described the matrix. So a matrix like this one, like the one I just showed you, when we're talking about rows, we're talking about the horizontal alignment of the numbers. So going across, 6, 4, and 24 are in one row. And so rows are going across like that. And likewise, there's another row here, 1, -9, and 2. So there are 2 rows in this matrix. So that's what we talk about. When we talk about the rows, we're talking about that horizontal arrangement. If we think about columns, those are the vertical arrangements, meaning it's going from, if you think about a column in a building, it's always going to be vertical like that, going down like that. So we have our columns. So this matrix actually has 2 rows and 3 columns, right? And so we refer to this matrix as a 2 by 3 matrix. We will always state the rows first. So when I describe a matrix, I will always start by saying, if I say it's a 1 by 3 matrix, it means there's 1 row and 3 columns. There's no confusion. You need to make sure that you notice that it's always row, then column at all times. That's the agreement for all mathematicians in the world, that matrices will always be described by the rows and the columns. First, do not ask why. I don't know. It could have been the first person who started to work at matrices that decided that the best thing to do is to do it this way. So that's the way it is. But matrices are always defined by the rows times the column. And it's always like, we would say, not say a 2 times 3, we'd say a 2 by 3 matrix. That's what we would refer to this one as a 2 by 3 matrix. Now, as we begin to study matrices, there are some matrices, I just want to add this as information. And they are what they are, but I'll call them special matrices. There are other matrices that I'll come across through the presentation, but then I'll describe those with maybe the math that is surrounding those matrices. But there are some that there's no math leading up to it. It's just what they are. And so I'll just tell you what these are. So for example, this is a 3 by 3 matrix because it has 3 rows and 3 columns, remember? Now, when a matrix has the same number of rows and columns, meaning the rows and the columns are the same in terms of numbers, it is called a square matrix. Can anybody think about why this would be called a square matrix? Any ideas why we would call this a square matrix? Exactly. And it looked like a square, isn't it? Right? Exactly. So there's a reason why we call it a square matrix, because it looked like a square. So you can see that square right around the matrix. Now, that is a specific type of matrix. It's called a square matrix. But could you give me another example of a matrix without writing it? Just tell me, describe a matrix that would also be a square matrix. 2 by 2, 4 by 4. Is it possible to have a 1 by 1 matrix? Like a 1 by 1 matrix, isn't it? Is it? It would be one number, but it would be a 1 row by 1 column matrix. Actually, it's possible to have a matrix with 1 row and 1 column, but it's not a proper, the ones that we would look at. So that would be your unit matrix in that sense. All right, so someone mentioned a 2 by 2 matrix. This is a special type of matrix, this one as well. This is the identity matrix, and it has 1 and 0 in the diagonals. The ones will start in what we call the leading diagonal, okay? So this is the leading diagonal. The first diagonal as you enter the matrix, and when we think of diagonal, it's that line going across that square in that sense. So it's called the identity matrix, and it has a 1 and 0 in the diagonals. 1 in the leading diagonals, and the other diagonal will just have zeros. It's just the name of the matrix, and there are some uses for it. And when we start to multiply matrices, I think someone is, yeah, thank you, Shavin, because I was wondering who is attacking me like that. All right, so the identity matrix is a name of a type of matrix. It has use. It's just like the identity in mathematics, in numbers, 1. If you multiply by this matrix, it doesn't change the matrix. The answer just turns out to be the same. All right, but it's a special type of matrix, and you might be doing a multiple choice, and it might ask you which of these is the identity matrix, you know, or which of these is not, you know, something like that. So it depends on the question. Another matrix that you could know right away is the null matrix or 0 matrix. All the elements in the matrix is 0. So I use the term elements, the part of a matrix, each of these numbers or objects are referred to as elements. So all the elements in the matrix, 0. Okay, that makes it a null matrix. And effectively, if you multiply by this, you'll get 0. That's what would happen. You just get the null matrix back, and it functions just like 0. And if you add it to something, it doesn't change the value of the matrix. So these are some special ones. There are others which I'll speak about as I go through the presentation, but those will arise from the mathematics that goes into it. All right, so So we're going to start off with some basic operations on matrices, and I hope to build through to the different topics. Hello? Okay, remember that I'm going to share all of this, so you don't have to really screenshot if you want. All this is shared normally at the end of the lesson in the WhatsApp group, and it's on YouTube as well. The same YouTube link, it will be there, so you can always get it. But no problem if you want to screenshot it as well. Finish? Let me just have a look and see how YouTube is. Okay, no problem. All right, so let's carry on. So we're going to have a look now at different operations. So I'm going to do addition, I'm going to do subtraction, and I'm going to do multiplication. And we'll talk about each of those. So adding matrices, let's say we have two matrices to add. The key thing to understand about adding matrices is that we add the elements that are in the same position in the matrix, all right? So for example, we add the 8 with the 7. Let's think about what I mean here. So this matrix, the position here is in the first row, first column kind of position, first row, second column position. We look for the numbers which are in the same, the elements which are in the same position in the matrix, and we can just add them. So when we're adding matrices, we just look for those and we put them together. So if we were going to add this matrix, what we'd get, 8 and 7, first one would give you 15. Then we'd look for 5 and 4. The order doesn't matter, but I have a habit of doing things in the same way all the time. So I do 5 and 4. That gives me 9. Then I'll do 2 plus 0. That would give us 2. And then 4 plus 2 will give us 6. So adding matrices, are there any problems you think you might have adding matrices together? Okay, I'm taking. What a powerful question. Could you repeat that question, please? Okay, so when you say two different matrices, what do you mean by that? Which square matrix? You have to give me a specific example. So the identity matrix is a 2 by 2 matrix, right? It could be, actually, that's just the 2 by 2 identity matrix. The identity matrix can even be a 3 by 3, but then you'll have ones all across and zeros going through. But I'm trying to understand your question to answer you, that's all. So you said to me at the beginning, what if the matrices are different? And I'm asking you to give me an example of what you mean. Okay, so you mean like if you have like a 3 by 3 and a 5 by 2 to add, right? That's what you're saying. You cannot add matrices. So this is something you can even make a note of. You cannot add matrices that do not have the same, they are not the same order. They are not the same order, meaning they are not 2 by 2. So you can only add 2 by 2 with 2 by 2 and 3 by 3 with 3 by 3. Because you can see the problem, right? If you're adding the corresponding elements in positions like they are, it's not possible to do that if the matrices are two different types. Does that make sense? Does that make sense? That, yeah, because if they don't have similar corresponding positions, you cannot add them. So if it's a 3 by 2 to add to a 5 by 7, they cannot be added because you don't have the same positions to add into. And the same rule will apply for subtraction because you'll find that subtraction is similar. All right, so let's look at an example. Find the value of x and y. It's the same thing because a vector, really, think about a vector. Does a vector remind you of a matrix? It is. It is a matrix, and a vector is actually a column matrix because it has, well, the ones that you'll do will have 2 rows and 1 column. So it's a 2 by 1 matrix. So the procedure for adding vectors and adding matrices are the same, which is why we tend to do matrices first and then do vectors afterwards, because then you don't have to learn those skills. Again, so a vector is a matrix, and vectors can get very big as well. All right, so find the value of x and y from the matrices below. Now, I'm throwing an answer to the question here just to show you the nature of how this could change into a different type of question. So we have 8, y, 1, and 5, and one matrix, and we have 2, 4, 6, and 2x. And we have 10, 9, 7, and 11 as the problem. Any ideas how we go about finding y or 2x? Any ideas? Why? Exactly. Yep. Anybody disagree with that? No? So if we're finding y, we know that this is how I approach. I say y plus 4 is 9. Do we agree? Yeah. And then I am having a simple equation. Y is 9 minus 4, so y must be 5. So that's what you said, but I tend to approach it in a systematic way. That's just it. But it doesn't mean you have to. These are type of stuff you might see in a multiple choice, yeah, question. So it's quick. You kind of go, oh yeah, y plus 4 is 9. Okay, good. Let's look at the next one. What do we do for this one though? This looks a little bit tricky. Yeah. Exactly. So I'd start off with my equation again, right? So 5 plus 2x must be 11, right? And then I can just solve. 2x is 11 minus 5, right? 2x is 6, and then x must be 3. So why am I'm practicing my algebra as well. You know, when I know the answer, it's good to practice my algebra. Make sure that I develop a skill set with my algebra for easy ones. So when I get to the more challenging ones, I am happy. I know my algebra works irrespective of that problem. All right. So far, so good. Okay. So let's carry on. Have a go. I'm leaving this one for you to start in. I'm going to give you a minute head start and then I'll work through it. So 1 minute to give you a chance to just practice the skill, and then we'll see if we are on the right track. Hold on to the answer. Hold on to the answer. Hold on to the answer. All right. I'm just giving you a chance to work through, and then we'll just see if the answers are. But I think you sound like you're on the right track. All right. So 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So I remember when we're adding, corresponding elements are added together. So we know that my brackets in first. So 1 plus 3 would be 4, as someone was saying. 3 plus 1 would still be 4, because we're taking these two now, right? This one with this one. And then 3 plus minus 1, that should give us 2. And then 0 plus 1 is 1. So if you have that matrix, then you know how to add matrix. It doesn't matter if there are different types of matrices. It doesn't matter the order of the matrix. The end result is that the corresponding elements are added or subtracted, because we're going to do subtraction. It's a similar procedure. What about this one then? What's the value of x and value of y? 30 seconds for each, or maybe a little bit more. 1 minute to have a go at this, and then I'll work through it. And we're at capacity again. Back to that. So subtracting, as I mentioned before, is also the same as addition, except where you would have normally added, you are now going to subtract. So we have what is the order of this matrix? 2 by 3. Remember that. Yeah. So someone asked, so it's a 2 by 3, and we're going to take away another 2 by 3. So that's okay, right? That's okay. All right. So how are we doing for time, sir? Oh dear, need to speed up. So we're going to subtract. The procedure is fairly the same. 5 take away 2, that should give us 3. 3 take away 3, that gives us 0. Minus 1 take away minus 1 should give us minus 2. 8 take away 0 is 8. Minus 2 take away minus 2 will become 0. And 3 minus 7 should give us minus 4. The procedure for subtraction and addition are essentially the same, except in the operation. So when you learn to add, you almost would say you have learned how to subtract. The procedure is the same. So I'm not going to spend too much time on that. Here's a question. Find the value of y. And I hope I don't make an error in the positioning of this one, because I might have been rushing through when I put this together. So just to carry on, because I want to get through some of this stuff. As I said, the video, you can pause it later on and watch it. So we have 3 minus 5 equals 26. And then we can work through that, all right? So we're going to need to continue, add 5. Just take the corresponding ones, and we're back to a nice equation. So you see, we can learn matrices, but if we can't do algebra, sometimes that can affect our ability to do well. So in this case, we need to make sure that we are doing this. 3y equals 31, and then y is just 31 over 3. And that's why it's important that we have the algebraic skills, because sometimes we are doing other topics and we end up having challenges and we think it's the matrix is a problem, but it's not. Sometimes we just don't have the other skills. When you have the algebraic skills, you can quickly go, hey, I know what to do. And I'm deliberately working these in an algebraic format for you to see how the different topics are connected. All right? Now, multiplication has 2 types of multiplication. You have what we call scalar multiplication, and we also have a matrix by matrix multiplication. So scalar multiplication is not really difficult to do. I'll just quickly show you what happened. And this is where we have a number multiplied by the matrix. So it's not really a complicated process. We take this number and we multiply, similar to what we would do for brackets. We take this number and multiply by each element. All right. So what would happen here? We do 3 times 8, 3 times 5, 3 times 2, and 3 times 4. So each element is multiplied by the number that is in front, similar to brackets. Nothing complicated. And then we just need to evaluate each of them nicely. 24, 15, 6, and 12. Right? Have a look at this example. I'm going to leave that for 2 minutes for you to have a start on those. So we have A, we have B, and I'm going to ask you to have a go at what is A plus B, what is 2B, and what is 3A plus 2B. So that's going to be a nice little practice question for you right now. So have a quick go at that. I'll give you 2 minutes to have a go at those, and then I'll work through those. Okay. Okay, I can. All right. Let's have a look and see what we have in YouTube. Okay, people are answering. Okay, so let's get going on working through. As I said, if you're anywhere halfway between, you'll see what's happening and you can just catch up and see where you are. So this is a typical type of matrix question. You'll normally be given some matrices and you're asked to do some calculations with those matrices. In this case, we're asked to be adding them. And just a kind of recap of what I've covered so far. So for the first one, we're going to add these matrices. We know that we're adding these matrices, we're adding the corresponding elements, and we're putting the answer in the same position that they were. So 8 plus 2 will give us 10. 0 plus 4 would give us 4. 1 plus minus 6 is minus 5. And 5 plus 3 is 8. So if you're getting that, then you know how to add matrices. You can tick that off your list. All right, so that's the easy one. Then we're asked to work out 2b. We need to make sure we identify the correct matrix. And then we're going to multiply by 2. I'm always mindful when I'm working through this. Was I in the right frame of mind? I might have made an error. I don't know. Let's see. 2 by 2 is 4. 2 by 4 is 8. 2 times minus 6 is minus 12. And 2 by 3 is 6. So that should be fairly straightforward. Now, how do we jump all the way from a plus b and 2b to now 3a minus 2b? Now, remember that 3a means 3 times a, and 2b means 2 times b. So we just literally are putting that together, and it would look something like this. 3a is 3 times a, and we're going to take away 2 times b. That's literally what you're asked to do. First step, we can get rid of the multiplier. So we would end up with, in the first one, 24, 0, 3, and 15. All right? In the second one, we've already done 2b, and most times in exam questions, they tend to have some of the work already done, but I'll still, so we can replace that with 4, 8, minus 12, and 6. Now we're subtracting, so we'll have 24 minus 4, that should give us 20. 0 minus 8 should give you minus 8. 3 minus minus 12, so we know we're going to be adding to get positive 15, and 15 minus 6 should give us 9. Nice question, right? So if you've gotten through that, then it means you're beginning to get the basics of how matrices work. And that's maybe the more kind of the type of questions you have done so far with letters interspersed in it, as well as where we are asked to do like combination type of 3A, 2Bs. Those are the kind of things you need to be very quick on. All right, I'm mindful of time. Come again, please. Okay, hold on. What happened to me? I think it freeze. This thing, I look like it frozen. Sorry. Okay, where was I? Okay, go back. Sorry. Okay, yeah, it was a little bit frozen. We're good now. Okay, so you're asking me about the positive 15? Someone asking that? Okay, so 3 minus minus 12. Remember what we know about negative? With negative, what that becomes? A positive, right? So when the negative meets with the negative, so we get 3 plus 12, which gives us 15. All right? So these are the kind of things you just have to be mindful of. And as you do your math and build your confidence, those errors you will get used to them. You'll get used to avoiding them, looking that way. All right, so that's a practice question. Now, when Mr. William is working through with you, you will be able to get the chance to even go further with this. Now, the next type of multiplication that we have to learn to do, and I want to spend a little time. I know I started a little bit late. Let's see how it goes. Is multiplying a matrix by a matrix. Now, I'm not going to get too far into it because there are some other aspects of it, and we will get to that maybe later if we're kind of revising matrices, but I'm just going to go through the basics, and I'm going to use just a 2 by 2 matrix to multiply by a 2 by 2 matrix. And then later on, we can maybe look at, other types of matrices and see how that works. But just because today I was trying to get through the basics of multiplying, because once you master it for one type of matrix or one pair of matrix, then you'll be able to apply it to other matrices with a little bit of adjustment, but you'll understand the processes, and that's the most important thing. So what you'll find is that you'll get two matrices like this, and you'll maybe asked to do A plus B and 2A and 2B and 5A minus 3B and all those stuff. But sometimes you'll come across a question that says, find AB. Now, just like in algebra, AB means A times B. But unlike the other ways in which we have added and subtracted, multiplying matrices is a little bit more of a process. And here you're going to have to just remember the process, because the methodology for this is not something that I could say here is the reason for it. It's just that when you multiply matrices, there's a certain sequence of activities that you must follow, and you need to remember that. And that's going to be the hardest thing until you remember it. Once you are competent at multiplying matrices using this procedure, then you don't have to worry about it again. It's like riding a bicycle. Once you know to do it, but initially, I imagine that you might go, I'm not too sure here or there. So the first time, you really just want to get the information. After that, you might start thinking, I wonder if I know this or not. Practice over time, maybe even today, tomorrow, and so on. You'll be able to say, no, I get it. So don't worry today if even today you kind of go, I think I'm just following steps, but I'm not sure. Don't worry about it. There's a process in this, and it takes a little bit of time. All right, so when you're multiplying matrices, there's a specific procedure that has to be followed. All right, and it's important that you do this. So as I said, AB means A times B. Now the process for multiplying requires us to do a row by column operation. So we're going to take the row and multiply it by the column. So we're going to multiply that row. So remember I said it's a 2 by 2 matrix and the rows are going across. So we're going to take this row that has 8 and 0, and we're going to multiply this row by the column that has 2 and minus 6. So you can see this column. So first row by first column. We're going to do this. This is how it works. You always multiply an entire row by the entire column. Always. Now, how do we do this? The procedure is, once you recognize that you're going to do a row by this column, you kind of imagine that this first one will go with this one if I put them side by side, and this one will go with this one, and it will look like this. Let me explain. So we'll do 8 times 2 plus, always a plus, 0 times minus 6. That's how we multiply a row by a column. First element in the row multiplied by the first element in the column, and the second element in the row multiplied by the second element in the column. And if there's another element in the row, you do that the same. You always correspond like that, but we're going to go row by column. Because we're multiplying the first row by the first column, then the answer must go in the first row, first column as well. So the operation that you do goes into the same position that you're doing. First row by first column. The same procedure is continued for the second column. So now we're multiplying first row by second column. And you're going to get something looking like this. 8 times 4 plus, always a plus, 0 times 3. And that's the procedure that you apply. Again, we're doing first row times second column. So the answer goes in the first row, second column position. So as you do them, you can put them in the right place. You pack them in the right places. Same procedure is applied to the second row. So we go second row, multiply it by the first row, and the same, the 1 will go with the 2, and the 5 will go with the 6, because if you turn it, it's just going to go upwards like that. And it looks like that. So 1 times 2, 5 times minus 6. Now, there are certain patterns you'll see here. Always times, always a plus. The only thing that changes, nothing changes except the numbers. It's always times and a plus. So you don't have to think, what is it, when is it at always? Is it a plus in between the numbers all the time? Yes. So you will only be multiplying in this way. And once you've done that row, that column, you do the same for the last column. So again, you'll get 1 times 4 and 5 times 3. Before I go on, are there any questions you might have? Okay. So remember that we're doing row by column. I'll go through it once more because we have other examples you'll be able to practice this. And I remember the first time that I saw this, I just need to practice it, but I'll go through again. So it's row by column. So once you identify the first row, you're going to do row by column. And we are going to get that. So 8 times 2 and 0 times minus 6. We write that down. We're not finished yet. We just write that down. Same procedure, but on the second column. And again, it's done in the same. And you get that answer. 8 times 4 and 0 times 3. Once you've gotten the first row sorted, we switch row to the second row. And we apply the same procedure to the first column to get 1 times 2 and 5 times minus 6. And then we apply the same procedure to the last column. And we'll get this. Now it's not finished as yet. Now we need to simplify. So once we get that, we can now simplify. We know that 8 times 2 is 16 and 0 times minus 6 will just give you 0. So we get 16 plus 0. So we do the multiplications and get those out of the way. Likewise, we'll have 32 plus 0, because 0 times 3 is 0. Because negative 0 is still 0. There's no negative. Remember that 0 is the bar there, you know. When it's at 0, it's neither negative or positive. So that's why. Yeah. And then we have 1 times 2 and 5 times minus 6, which will give us 2 plus minus 30. And then the last one will have 4 plus 15. So we're just going to finalize the simplification now to get to the final answer. And that's just adding, simplifying. So 16 plus 0 would give us 16. 32 plus 0 would give us 32. 2 plus minus 30 would be a negative 28. And 4 plus 15 will be 19. It's your first time. First thing that you're trying to understand is the procedure. All right. There are certain clues that you can look at, but I won't share those yet, and I hope you can identify them yourself. But the procedure is fairly, just remember what it is. In this case, in math, I'd say just remember that procedure, because the steps that you're using to do this is already what they are. And there's no real shortcut, no other way of understanding this. This is how it works for this type of calculation for matrices. So you just have to remember that. And I'll do another example anyway, so you'll be able to see how that works again. Yep. So you could get, so good question. So you're asking if it's possible to have like 3 matrices to multiply. It's possible. And what may happen, what you'll have to do in that scenario, so you wouldn't be able to multiply 3 matrices in one calculation. You'd have to multiply the 2 matrices, 2 of the matrices first, then take that answer and multiply by the other matrix. Well, for addition and subtraction, if you think about it, would you think it would change much if I gave you 3 matrices side by side to add? No, because you just have just corresponding positions. That's all. So even if it's 5 of them in line, it wouldn't affect the work. You just need to do. You could still do 2 first and then do the next one afterwards. But the main thing is that it wouldn't change the work. But for multiplication, it does affect the work. Yeah, you'd have to multiply the 2 matrices together and then take the answer and multiply the other matrix. And you will maybe see examples like those where you can practice that. All right. Not in this, but I'm sure when Mr. William is working through it, he will do some like those. Don't worry about it. All right. I mean, okay. So the other thing here I have BA. I'm going to give you a minute or two, maybe a minute to have a go at starting this. And then I'll work through it. So you don't have to worry about working through the end. I just want you to start it to think about whether you know what I was shown. And you have a minute or so to get going, then I'll pick it up. All right, so 1 minute. All right. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So let's get going. Let's see where we are in that process. As I said, you don't have to finish. You just need to be starting to get a feel of it. And we're just going to do BA. It's the same 2 matrices as the one that we had before. And we did A times B. So we're going to do B times A now to see if it's the same answer. All right. And that's important to know because sometimes we assume that these things are okay. It's going to be like this all the time. So B times A means we put B at the front and put A in the second position. Okay. So we carry on. We get a row, first column. And we know that the 2 is going to operate with the 8 and the 4 is going to operate with the 1 to get 2 times 8 plus 4 times 1. We continue. Now we move on to the second column. Same procedure. This time the 2 is going to work on the 0 and the 4. And the 4, hold on, I have a little bit of a freeze here. Okay. And the 4 is going to work on the 5. So we'll get 2 times 0 and 4 times 5. Once we have finished the top row, we go to the second row. And now we're going to do that same set of operations, but now on the first column with the second row. So -6 will work on the 8 and 3 will work on the 1. Again, remember, it's always going to be times and it's always going to be plus between the 2. And then the last stage of the multiplication is now to do -6 with 0 and 3 with 5. So now we have the multiplication steps, and I'd recommend that when you're just doing this, do all of these steps. You'll notice as well as you work through that these numbers are the same, always the same. Look, the middle, They're equal to each other. So you can see those are the patterns if you're thinking, maybe I made a mistake. If you made a mistake, those things will be out of sync. Okay, so let's simplify. We have 2 times 8 plus 4 times 1, so that gives us 16 plus 4. We have 2 times 0 plus 4 times 5. We know that 2 times 0 is 0, so it's 0 plus 20. We have minus 6 times 8 plus 3 times 1. So minus 6 times 8 is 6 times 8 first, which is 48, and we multiply the negative times a positive, so we get negative 48 and a plus 3. And our last term, minus 6, minus last element, we're going to get 0 plus 15. Simplifying, we have 16 plus 4, which is 20. 0 plus 20, which is 20. Minus 48 plus 3, which is minus 45. And 0 plus 15, which is 15. So if you're anywhere... Yeah, we know we have to get things done, of course. All right, so here we have, this is the situation. So just make sure that you are, if you're working through it, main thing is to understand the steps. And then as you practice, you can then become more independent with those steps. So it's not a matter of you saying you're mastering it. No, it's just knowing how you go about it. And then you can develop the understanding through practice. All right, but the main point that I wanted to talk about here as well is that, do you notice that A times B is not the same as B times A? Did you see that? No one saw that? That AB is not, so AB is not the same as BA. So what does that mean for you when you're asked to multiply the matrices? Yep, get the order right. You have to get the order right. What's happening here? Get the order right. That's very important that you get the order correct. All right, that's very important. So if it says BA, don't just go, well, I like my alphabet and it should be AB. That's going to give a different answer. That's the point. If it says AB, then you must do it in that order. PQ, PR. You just make sure that you put the first matrix first and the second matrix second, because the answer, they're not the same. All right, so Mr. William, if I have about 10 minutes, I might be able to get through to inverse, yeah? Where is he? I actually started at 9:36, so I'm just begging 10 minutes extra. So we're going to go through the last few points in matrices. So multiplication, we can do some practice, so we can develop that, and Mr. Fullerton will go through some practice questions with you. That's not an issue. I'm going to share 3 other concepts with you, and you should be okay after that. All right? So the first one is a determinant of a matrix. Now, the determinant of a matrix can be written in a number of ways. You could see a question that just says, find the determinant of the matrix. And the word determinant is there, and there's no need to be confused. You could also see det A, short for determinant, find det A. And it's the same procedure. I'm just saying that there are many ways in which you could see this in an exam. And the last one is with the matrix with 2 straight lines on either side. And it just means find the determinant of the matrix. So all 3 representations are okay, and depending on the question and the exam, you might see different things, depending on what they're trying to check with you and in the assessment. So if you see any of these, you know, I need to find the determinant. Now I'll take you through the process for finding the determinant. So we have 2 matrices, A and B. Find the determinant of A. So how do we find the determinant of A? To understand the concept of the determinant, we first need to understand what we call the leading diagonal. So we have what we call the leading diagonal, meaning there's a diagonal, there are two diagonals in the matrix. We have one that goes this way, and we have another one going that way. But I know you'd also realize that if you're talking about diagonals, we're working on a square matrix. Only square matrices will be able to do this kind of work. So we take the leading diagonal to start, which is as you enter the matrix, it's going to be from first row, first column, and then diagonal after that. All right, that's called the leading diagonal. The procedure here is we will, for determinant of A, we'll multiply 8 times 5, and then we take away 1 times 3. So we will multiply, but the leading diagonal is the one that we use to start the problem. So we always do first row, first column, start there, and then multiply, and then we repeat the same multiplication on the other side, but we subtract it. So it's going to be, as I said, for this one, to find the determinant of A, 8 times 5, take away 1 times 3. That takeaway is permanent in the determinant formula. Okay, this is a formula for determinant. It's permanent, and we always begin with the leading diagonal. Just like when you're doing the other stuff in trigonometry and all that, it's important that when you look at the matrix, you know where the leading diagonal is. That's going to be very, very critical as we do the rest of this work. So at all times, that's your leading diagonal. The first row, first column starting point. And then we simplify like normal. 8 times 5, take away 1 times 3. 8 times 5 is 40. 1 times 3 is 3. And so our determinant is just 37. And determinant is a number. It's not a matrix, it's a number. Any questions? No problem. So remember that determinant is a function of the matrix. You'll just be asked, find the determinant. So what I'm doing here is just showing you how to do the determinant. So we need to identify the leading diagonal in the matrix and multiply the terms along that. So the determinant of A is 8 times 5, take away 1 times 3. First row, first column, and then you know where it is. So once it always starts from the first row, first column element. Because 3 times 1 and 1 times 3 would be the same anyway. So it wouldn't matter even if I had said 5 times 8. But for simplicity, I'd say just keep the same order through it because it wouldn't change the answer. All right, but if you had written 3 by 1, it's okay. It's not a problem. And if I had written 5 times 8, it wouldn't have mattered as well. Because remember, we're multiplying. And in this case, multiplying numbers, the order doesn't matter. But you just realize that for matrices, multiplying the order does matter. Yeah, so it's something to remember where matrices, in that sense, there's a term for that. We call it commutative, the commutative law. It doesn't apply to matrices for multiplication, but it does for numbers. Don't want to confuse it too much. So 8 times 5 minus 1 times 3 gives us 40 minus 3. We have 37. The determinant is just a number, and it's done. That's a determinant. It's 37. Question is finished. So if you're doing multiple choice questions, they might throw this in. And as I said, there are other stuff that I'm going to get into very, very quickly that will, the determinant, here's a nice question for you. Find the determinant of B. We want to have a go at that. Give you a minute. Find the determinant of B based on the rule that I just shared. 1 minute, and then I'll work through it like normal. Not yet. Hold on to the answers. If you have it, just hold it, and then, you know, at the end you can, when you work with Mr. Fullerton, he'll give you, because he has a pen to write and all that kind of stuff. I just want you to work it out and then feel, you know, in yourself, you know, yeah, I think I got it. That's great. Let's have a go. So we identified the leading diagonal. Always important to do that. And then we can do the rest of the work. The determinant of B would be 2 times 3. Take away 4 times minus 6 or minus 6 times 4. So that's the first stage. And if you write that down, if it's a 2-mark question, that's 1 mark already because you have stated the correct method. Then we can do the math. We have 6 take away minus 24. So notice I'm separating the work, keeping the minus in its own little space. I've deliberately put that in red so you keep that clear, and do the multiplication, minus 6 times 4, which is minus 24. Now we have to deal with the face-off of the negative signs, and we know that becomes a positive. And so the determinant is 30. Was that okay for you? Okay, good, 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 good. So we have the determinant. We have 2 more concepts. Oh, I have one nice question for you here. Find this determinant for me quickly. Again, quickly. Find the determinant of P. Or somebody say it's gonna be 0. Let's check. Find the leading diagonal. Then we go, remember that notation, determinant of P. Get used to all the different notations. So we get 4 times 5 minus 2 times 10, 20 by 20, take away 20, and we get 0. Now, a matrix that has a determinant of 0 has a special name. All right, it's a special matrix. And a matrix that determinant of 0 is called a singular matrix. All right, very important to know it's a special type of matrix. So for you to know, it works in both ways. If you see a question and it says, the following matrix is singular, yeah, then you know right away that the determinant is 0. This is something you need to always connect in both ways. So you can work the question and you get the matrix, the determinant to be 0, and it says what type of matrix? And you go, it is a singular matrix. Or you could have information given to you where it could say, this matrix is singular, and they ask you to do something. Remember that if it is singular, the most important thing to remember about that is that the determinant is 0. So this is an example of a singular matrix. Now, if I had the time, I maybe would give you some mixed matrix and say to you, fill in the pieces to make it singular, that kind of thing. But I won't be able to do that with you because time is going and I'm running out of time now. I'm going to be told that I took up too much time. All right, so we have 2 more concepts. So we went through that. Sorry, I must have did that twice. Okay, the next part of the matrix that we need to practice is called the adjoint of the matrix. So these are other things that you may be asked to do with a matrix. Now, the adjoint is not a calculation. It's a rearrangement of the matrix. So you're not calculating, you're just rearranging the matrix in a specific form. Again, information, and then you apply that information to know what the adjoint is. And with practice, you will remember that. But for now, it may seem a bit weird. What is he doing to the matrix? So we have the matrix Q, and we're going to find the adjoint of the matrix. Adjoint is a simple procedure. You need to remember where the leading diagonal is. Very important. So the first step in the adjoint is identifying the leading diagonal, and we just switch the leading diagonal. So we're going to switch the numbers. So where there's 5, we put 4, and where there's 4, we'll put 5. We just switch these 2. All right, this is a procedure that you need to remember. It's not like I can go through it step by step. It's just a procedure. And then we change the signs on the other diagonal, meaning we're going to change the signs along this diagonal. So whatever is a sign, when I say change the sign, it's a negative, it will become positive. It's a positive, it will become a negative. That's it. So if you're asked to create the adjoint, we just need to do switch 5 and 4. Yep. So that's the first stage, switch, and then change signs. That's it. So if in this case, adjoint of Q, switch 5 and 4. So switch along the leading diagonal, and then change signs along the other diagonal. That's it. That makes the adjoint of the matrix. And that's, in you see a question that says, find the adjoint of the matrix. That's what they're asking you to do. Just switch, and it's done. Yep, listening? Could you repeat that question? I didn't hear that question, and I want to repeat. How do you know? This is the adjoint. The adjoint is one step, is a new matrix. And there are a set of things you have to do with the original matrix to make it the adjoint matrix. Does that make sense? Okay, we're coming to that. We're coming to that. We're coming to that. I know, yeah, but we're not there yet, and we're not going to do that today. But it's all part of the process. You will. I know what you're asking me now. Okay, I know what you're asking me. That's another stage in the process. At the moment, we're just doing the adjoint as a separate thing. So this is how we do the adjoint. Let's look at another one. Have a go at doing the adjoint. I'll give you 30 seconds. It shouldn't take you long enough to just write down and make the move. 30 seconds. 9:49. Oh. And again, I'll give you lots of practice on this and say, put it together. So it's really just a rearrangement. 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So in the adjoint, remember, the leading diagonal gives us a clue what to do. So we switch them, and then we change signs on the other diagonal. So first move, 2 and 3, and you do them in this order. Just switch them first, and then change signs. And you will know that 0 doesn't have a negative, right? So it will just be 2, 5, 0, 3. All right? That's how we do it. That's the adjoint. The last concept, and then, hold on, I have another one here. Again, same idea. Adjoint of the matrix. Yep. The negative 0. Well, negative 0 is the same as 0. We don't really put a sign in front of 0 because it's just 0. So even if you're working and you put a 0, when you're writing the final answer, just put 0. You don't need to put a negative sign because it doesn't convey any idea. The 0 is in the middle anyway. So this one again, the same idea. I'll just go through this quite quickly. Switch the -1 with the 2, and then change signs along the other side. And students make mistakes on these because sometimes they forget which one to switch. So just remember that you switch the leading diagonal. And then after that, and when we switch, notice we're not doing anything to the signs. We're just switching. Okay? -1 goes to the top, 2 goes in the bottom, and then we change this. All right? That's the adjoint. Now the final concept is the inverse. And then Mr. Fullerton will have his time. So we have a matrix, 5, 3, 1, -2. Now the inverse of a matrix is really just a combination of the determinant and the adjoint. So if you know to find the determinant and you know to find the adjoint, then you'll know how to write the inverse of the matrix. So really, once you do the determinant and the adjoint, you just simply need to put them together in a specific order. So the formula is really putting 1 over the determinant. Remember, the determinant is a number, and multiplying that by the adjoint. So Let's look at this example to see what I mean. Now, there are two ways you could be asked to find the inverse of the matrix, or you could see n to the power of -1. Same. So the first thing we need to do with the matrix is find the determinant. And we know how to do that. 5 times -2, right? And 1 times 3. And we take those away. Carry on. -10 minus 3 gives us -13. So we found the determinant. We're going a little bit fast now, but that's how we find the determinant. We've done that before. The next thing we need to do is work out the adjoint. And we would know the adjoint because we have already done that. We just need to switch -2 with 5 and change signs. And then we're done. Then we write the inverse. 1 over the determinant, which we know is -13, and then just multiply by the adjoint. And that gets you the inverse. And then we get rid of the multiplication sign because we don't really need it. And we have that. If needed, you could just divide each of the terms inside by -13, but this is normally okay. But you can put the -13 in, and I'll do that in the final example. Remember, the procedure is we know that to find the inverse of a matrix, it's 1 over the determinant. We know how to find determinant already. We also multiply that by the adjoint. Okay? So we're just going to find the determinant, find the adjoint, and then put it together. That's all. So first step, find the determinant. We know how to do that. Leading diagonal, take away the other diagonal, multiply. -10 minus 3 gives us -13. So we have found the determinant. That's the first part of the formula. Okay, 1 over that. Second part, find the adjoint. Find the adjoint of n. We know how to do that. We just swap in -2 and 5 and change in signs. That's what we just looked at. So that's the two pieces. We're just going to replace these here and this -13 here. And write the inverse. So we don't have to do any calculation. We'll just write it. 1 over the determinant times adjoint. And then we can get rid of that sign. All right? Final. Find the determinant. 2 times -3, 1 times -1, which gives us -6 minus -1, which gives us -5. Find the adjoint. We know how to do that.
And matrix N. And here it asks us to evaluate L minus N squared. So we need to do something here. We need to first of all evaluate or find N squared, and then we're going to find the difference between L and N squared. So I'm going to give you 3 minutes. That's our thing that we do. We work through with time, because that's important when we are doing that. So I'm going to give you 3 minutes to work through this question, and then there is someone who will help me to go through this question, remembering something here. So first of all, N squared. What is N squared asking us to do? N square is
Times
saying
n by itself.
You multiply
n,
by itself.
yes, n times n. And so the matrix here is a 2 by 2 matrix, negative 1, 3, 0, 2, and you're going to multiply it by itself. And so that's finding the product here. Yes, and the product, and I would write it here, and I'd say negative 1, 3, 0, 2 times negative 1, 3, 0, 2. So here we've got a product that we can work with. So I'm going to give you 3 minutes to do that, and then we do the other part of it. Give you a chance. Ten seconds. Yes, so our time is up. Who wants to help me to solve this question? Anybody wants to help me?
Sir, first.
Oh, who's that? Adrian?
Yes, this is Adrian.
Adiiel? Yes? Okay, good. So work with me now, Adrian.
Okay, first you'll have to multiply the first row by the first column. So
Okay.
that's negative 1 times negative 1 plus 3 times 0.
Yes, so that would give me a 0, yes? So we don't have to put anything there, right? And let's go across now.
Okay, and then you'll continue to use that first row to multiply the second column, where you'll have negative 1 times 3 plus 3 times 3.
Plus, you sure?
3
Times
plus, oh, sorry, yes, 3 times 2, sorry.
Okay, that's fine. And then what
Yes.
do we do for the next
The
segment?
bottom row, yes, we go to the second row and we multiply the second row by the first column, which would give 0 times negative 1 plus 2 times 0, which would be 0. And then we'll multiply for the other side 0 times 3 plus 2 times 2.
And so our matrix there would be 1, what's that? 3, 0, 4. So now we're going to do the subtraction, which is 3, 2, 1, 4 minus 1, 3, 0, 4. Yes? And what's the solution?
Yes.
Adrian? You forget me, Adrian?
Yes, sir. One. No, I'm still here. So that's 3 minus 1, which would be 2. And on the other side, you have 2 minus 3, which would be negative 1. And then underneath that, you'll have 1 minus 0, which would be 0.
Sorry?
Sorry, 1, sorry. And you'll have 4 minus 4, which would be 0.
Okay. And that's our response there. Okay? So that's part A there. And part B, it says, we speak about a singular matrix. And it says, matrix M is given as x12, 3x. And the question says, calculate the value of x for which M is a singular matrix. What do we know about singular matrix?
Their determinant is equal to 0.
That a determinant is equal to
0, sir.
0. So what should we have here now? How do we find the determinant? The determinant is the product of the main diagonal minus the product of the minor diagonal. What's the main diagonal in this case? The diagonal that runs from top left to bottom right. So it's going to be x times x, which gives us x squared. Yes? Why did you say times 3?
Sorry, sir, I was seeing it wrong.
Okay, sorry. And the minor diagonal goes across here. So minus 36, and that answer is going to be 0. So if x squared minus 36 is equal to 0, then we know that x squared would be equal to 36. So what's the value of x?
The square root of 36.
The value of x is
6.
Did you read the question carefully? The question says calculate the values of x. So what are the value?
Negative 6.
Negative x. Negative 6. So the value of x, I would say, you could write it as plus or minus 6. Okay?
Yes, sir.
Okay. All right. We won't be able to do the other parts because we're not there yet. Yes? But here's another question now. Now, this part that I gave you with the asterisk, please, we're not there yet. So I'm going to draw a line there again for us. And let us approach the question above. So that's 3 minutes. And I want you to do both parts of that question now.
How much time, sir?
Only 3 minutes, Kingsley. You know that. We're not going, the number of marks, the number of minutes. No more. 15 seconds. Who's working with me with this one now?
I'll try.
Okay, go ahead. Who's this one? Who's
Okay.
Brianna?
So, yes, sir.
Yes.
So the answer I got for this is 1001.
Oh. You think we're just gonna go from the question straight to the answer? Yes. 1001.
Oh, sorry. So
You're gonna help those of us who miss a few steps. So you're gonna help us to put those steps in. Yes.
okay, sir, no problem. So the first thing that we do, we have to look at the question. You're
Yeah.
multiplying, so you're not going to do what you do for adding. It's going to be different. So you're going to times the row, the first row by the first column, and the first row by the first column and the second column.
Okay, so we're going to be doing 1 times 5 plus 2 times negative 2.
Yes, sir.
We're doing this row by that column. Yes. So we're going to cross again, and we're going to multiply this row by that column. Yes. So it's going to be 1. Sorry. It's going to be 1 times negative 2 plus 2 times 1. Great. Now we're going to go repeat the process. This time we've got the second row by the first column, which is 2 times 5 plus 5 times negative 2. And I'm now going to go the same thing. I'm going to have this second row by the second column. So 2 times negative 2, that gives me 2 times negative 2 plus 5 times 1. And we do our simplification. So this will be 5 plus, that's 1. Yes? That part is 0, 0. And when we simplify this, is this 1? Yes, 1. Which matrix is this?
So you want the identity
For the
matrix.
2 by 2.
Yeah, the identity matrix.
It's a
Yeah.
2 by 2 matrix, but it is also the identity matrix. And with the identity matrix, whatever you multiply the identity matrix by, it gives you the same value. Okay?
Sir, is the identity matrix also known as the unit matrix?
No. Oh, no. No. Unit matrix. That slips me. I'll answer that question later on. No, I don't think so. The unit matrix is, that slipped me. No, I don't remember. Maybe Dr. Barker can talk me up on that one. But the identity matrix is the 1001. I think it is being used as that. I never happened to be using the unit matrix before. I don't remember having to teach it. But maybe that's the same thing, as it gives you that same unit. Yeah, maybe. Based on the term used. But the determinant of B, what's the determine B inverse? Anybody, you want to touch? Brianna, did you do the B inverse?
Yes, sir.
And what's?
I got 1/9.
How did? What is 1/9?
The B inverse. The 9. What I did was you have to change the arrangement. Like,
Good. So talk to me through that. Yes.
oh, okay. What I did was multiply the leading diagonal multiply and subtract the non-leading diagonal from that leading diagonal.
So
That's
you've
what I
got, okay. So you find the product of the main diagonal. So the determinant would be equal to 5 times 1 minus a negative 2 times negative 2. Yes? Is that what you're saying to me? In order
Yes,
to find the
sir.
determinant. So 5 times 1 is 5 minus 4. Yes? Is that 4? 2 times 2 is 4,
minus 4.
which gives us
Negative
what?
4.
Oh,
They get a 1.
negative 2 by a negative
Sir,
2.
is that negative 4?
It's positive
Yes,
4
sir,
and
I want
negative
to put
2.
there because the negative die is positive.
A negative times a negative inside here. A negative 2 times a negative 2 would give me a positive 4. And I
Question.
bring this negative down there. Yes.
So, sir, I thought you only like switch the leading
No, no, no.
diagonal and the non-leading in the adjoint.
Yeah, remember you've got to find, we haven't done the adjoint yet. All we're working is a determinant. We're calculating the determinant. We're then going to work the adjoint. So the determinant is to find the product of the main diagonal minus the product of the minor diagonal. And now we're going to work with the adjoint. And the adjoint would be to switch the main elements of the main diagonal. So we're going to talk about the adjoint. Which would be what? 1, 5, and we're
5.
changing the elements, the
Positive
sign
2.
of the minor. So the inverse, therefore, would be, we don't have to put 1 over 1, and we don't have to put 1 on the outside. It's going to be 1, 2, 2, 5. Now, the question was asked about the identity matrix. The unit matrix and the identity matrix are the same. So when you talk about unit matrix, it's the same thing as identity matrix. And Dr. Barker responded, yeah, I didn't notice that you responded there. Okay? Let's look at this. No, I don't want to touch this one because that's a little challenging. Let's do this one. I'm going to work with just part A you're doing. Just part A. We're finding the inverse of this matrix. You see that because of where we are in the work, what we have covered, the amount of work that we have covered, it's just enough to do part A of this question. Technically. There are other parts of it that you could have done, but you need a little more conceptual learning for you to know it. So in order to find the inverse, we need to find the determinant as well as to find the adjoint and put them together. So the determinant would be
Is 1 over negative 4.
Kayla. Help me, Kayla. Yes? Why did you say 1 over negative 4?
Yes,
How
sir.
did you get that?
Sir, dt that
Yes? Is equal to, how do you find the determinant?
Sorry, multiply the leading diagonal.
And the leading diagonal is 3 times 4.
4.
Thank you,
4.
Brianna. And we're finding the difference between that and the minor diagonal, which is 2 times 5. So here we've got 12 minus 10. So the determinant is 2.
2.
Okay. So how do we find the adjoint now? Adjoint?
So you're going to switch the elements for the leading diagonal.
We're going to switch the elements of the leading diagonal.
And the signs.
I switch a sign for the minor one.
Okay, so there are 2 different tasks or execution that needs to be taking place. We're going to switch the elements of the main diagonal. So I'm going to put 4, 3. And then I'm going to change the sign of the minor, which is -5, -2. So that's the adjoint. And so the determinant now becomes 1 over the determinant times 4, -5, -2. Okay? Are we good with that?
Yes, sir.
The other part of the question I don't want to approach, I don't want us to get confused in any way, so I'm going to leave it and just do the parts that we are confident on. We've got 6 minutes.
Do, C2, sir. Still try?
Say that again.
But if you can do C2, sir, can you still try?
Yes, 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 please do. Please do, my friend. Herman, I have no problem with that. But because I haven't shared that with everybody, I don't want you guys to be thrown off or confused as yet.
Sir, one question.
Sure, dear.
Sir, above, when you have for the inverse half and then you multiply it by the adjoint matrix, did you write half because you're from the inverse of 2, which should be 2 over 1?
No, yes, the determinant is 2, so it's 1 over the determinant.
So the rule is 1 over the determinant?
Yes, it's always 1 over the determinant times the adjoint.
Excuse me, sir.
Yes, sir.
So you can go back to the question on both, sir, and take a screenshot.
Above.
Yes, sir, this one. Okay, thanks.
Maya, you asked a brilliant question just now. Maya?
Okay, so I'm finished.
Yeah.
Sir, yes, I was asking if this is the way the simultaneous equation, but you solve it by the matrix method.
Maya, could you speak up? The person who's speaking about a simultaneous equation, could you speak up for me?
This question C, you said?
Yes. Can you try this part? We can try this part and I can work this last part through. So I'll work this entire question through. If that's what you're asking. I think that's what you're asking, Maya. So I'll work this question right through to the end. So I'll erase this line here so there are no limits on this one. Okay?
Sir, x is equal to 1 and y equal to 2 for C2, sir.
No, you're too unfair. For this particular question,
which one, sir? For C2, sir, simultaneous.
Herman, is it one before or this one? It's this question you're talking. No, you got.
Yes, sir.
Yeah, but Herman, you realize at the last part of the question, you know, what happened to the first part?
Maybe the others, sir.
Well, lead us through it, Herman. Lead us through it.
Oh, me confuse this with another one up at top.
You may figure say that, you know.
Yeah,
All right,
me
don't worry.
confuse.
All right, let's work through this nicely. This part of the question, part A or part BI asks us to find L plus 2M. Okay? Now, L is a 2 by 2 matrix, 3, 2, 1, 4, plus 2 times M, which is negative 1, 3, 0, 2. Yes? So I'm going to write this back. 3, 2, 1, 4. And I'm going to multiply, scalar multiplication here. And this becomes negative 2, 6, 0, 2. Agree?
4, sir.
Well, that's 4. Thank you.
4, sir.
Thank you.
You're welcome.
And now we're going to simplify because we're going to add corresponding elements. And 3 with negative 2 would give me 1. 2 with 6 will give me 8. And 1 with 0 would give me 1. And 4 with 4 would give me 8. Okay? So that's part 1. Then the question asks us also to find LM. LM is finding the product of 3, 2, 1, 4 with negative 1, 3, 0, 2. Good? And if you remember, in the first part of the lesson, this is a key part. This is a part that many students in the multiplication aspect of life will have a problem with. You will have a problem if you are not focused. But if you ensure that you follow the system, it will work. Okay, so we're going to do row by column to get row. That's what we're doing. So we're going to do 3 times negative 1 plus 2 times 0, which is 0. 3 times 3, which is 9. 2 times 2, which is 4. Now we are going to do row times column and then row by column. Okay? So we are going to have 1 times negative 1, which is negative 1 plus 0. And we are going to cross 3 times 1 is 3. 4 times 2 is 8. And if we simplify that, we will have what? Negative 3. 9 and 4 is 13 the last time I checked. 0 plus negative 1 is negative 1. And 8 and 3 remains 11. Am I right?
Yes, sir.
Yes, sir.
So when you're getting old, you will make mistakes. You know? But I say young people don't make mistakes anymore. Right? So
No, sir, that's not true.
That's not true. All right, just checking. Let's work part C now. Part C says matrix Q is such that Q is 4, 2, 1, 1. And it asks us to find Q to the negative 1. And Q to the negative 1 is asking you to find the inverse of Q. So Q is equal to that. And they're asking you to find the inverse. For you to find the inverse, first of all, you need to find the determinant. what's the determinant? The product of the main diagonal minus the product of the minor diagonal. So what we have here is 4 minus 2, so the determinant is 2. The adjoint would be to switch the elements of the main diagonal, switching it around, so I get 1 takes up the position of 4, and 4 takes up the position of 1 for the main diagonals, and we're going to change the sign of the minor diagonal. And so the inverse now, the inverse becomes 1/2 of 1, -2, -1, 4. That's our inverse. Good?
Yes, sir. Good.
Sir,
Yes, my dears.
can you please send a picture of this question in the group?
In the group, in the WhatsApp group,
Yes, sir.
we will do that. It's gonna be at the end, please. Let's finish this. It's coming to. I'm 4 minutes over, and I don't want to lose anybody else because they want to go and get their dinner, or prepare their meal, or something. Okay. Now, for this now, I think what was it? Tristan, was it? Herman worked this question before.
Yes, sir.
Okay. So what we need to do when we are doing this is notice a few things. I think, excuse me, I think Dr. Barkas mentioned that the inverse times its matrix gives us the identity matrix. Okay? And so if the inverse times the matrix gives you the identity matrix, and I'm just going to write things out for you. So that means 1, -2, -1, 4 times 4, 2, 1, 1 xy, because we are pre-multiplying it. So whatever you do to the left-hand side, you must do it to the right-hand side as well. 1, -2, -1, 4 of 8, 3. So what I've done is that I pre-multiply both sides of the equation by the inverse. And I am not going to work this portion out for you, but I'm going to tell you that this works out to be the identity matrix, which is 1, 0, 0, 1. And I'm multiplying that by xy. Now, I know, I'm not going on the right-hand side yet. I know that anything multiplied by the identity matrix gives you that, or the unit matrix. So I'm ending up with xy on that side. So I know that I've worked the left-hand side. Not because I've worked it, but because I know what the end products are. Okay? I use 2 principles. The first principle is that the matrix times its inverse gives us the identity matrix. And the second principle is that the identity matrix by anything gives you that. Okay? And on the right-hand side, I don't like working with fractions, so I'm going to write my fraction back. And I'm going to then multiply those 2 matrices. Okay? When I'm multiplying the 2 matrices, there is something that you need to understand, that we can multiply a 2 by 2 matrix with a 2 by 1 matrix. This tells us...
Sir, excuse me, sir.
Yes, boss.
Sir, some of them are, someone said they don't understand, sir. You should do it the way you're...
All right, hear what happened. You know what? let us leave it
Sir,
right
leave it
there
till next week.
till next week. Let me finish it off for those who have done it, yes? And then we will go take it on next week, okay?
And also,
Because
sir.
how you do it?
Sir, me do it when alright. I find the determinant first, sir, and then I find the inverse, and then in the adjoint, sir, I multiply it by x and y. So x and y are 8 and 3. So then me do 1 times 8, and then me
Oh, and
multiply
then you
them.
turn it into a simultaneous equation and you solve it.
Yes.
But it says use a matrix method. Use a matrix method.
Sir, it is a matrix method, sir. It
All
is a
right.
matrix method, sir.
Sir, could you solve it in the form of ax equal b by making x the subject of the equation?
I think that's what can be done here. You could say here is x, y is equal to the, and you put the matrix, the inverse, which is a half of 1, -2, -1, 4 times 8, 3. That's the same thing, yes? But I wanted to show you this part, what happens on this side. That's why, breaking it down. So I'm just showing you all the math that take place there, okay? So I don't want you to be confused too much. So let me quickly get this out of the way, and then next week we will do it. Yes? 1 times 8 is 8. 2 times 3 is -6. Yes? And then we've got 1 times 8 is -8. And 4 times 3 is 12. Yes? And so we've got a half of, is that 2? 2, and is that 4? Yes? Which says x and y, I am sure, came out to be 1, 2. Was that what you say, Herman?
Yes, sir.
So it's how we work them. Maybe I'm using my method from a different method, but it's a principle behind it, and then we can solve it. All right? So thank you, guys. Thank you for being here. Thank you for joining. We will see you again next week. Try and be early. I've got a few people who asked me a question. So if you come early next week, we can answer those questions so that we can move before we move into the conceptual learning, and then we will continue with matrices and the practices that are here. All right. Thank you, and enjoy the rest of the Sunday. Take care.
Sir, before